All right, day 12. We have a massive garden. The garden has a bunch of plants. The plants all have a position and they have a letter, which is an identification. This problem becomes a lot easier when we realize that a plant only, like once we split them up into groups, each group is handled completely separately, and they will never communicate with each other again. So after, like, if we just have the C's here, we can just treat them as its own separate group, so we don't care about the letter or anything else after that. First thing we have to do is get all of the plants. Iterate over the lines, and then we enumerate, so we get the row, and then we can flat map that. Here we get the I and the line, which is the row. So each row we then want to enumerate over every character. So we get the column as well. So enumerate and then map all of that. J, the column, and C, the character. What we're interested in is a position and a character. And for positions, I've already added the CG math to this. So I'm gonna make a typedef to say that vec2 is vector2 I size, just because we're gonna use this so much. So we're gonna select a vec2 ij, and the second part is the character, and in the end we have to collect it. I think it's right, as I size, and we want to use I size, so we can use minus and use negative numbers. We could collect this into a vec, and it would be totally fine, but just to make it run a bit faster when we split it into groups, I'm gonna collect it into a hash map, but we don't have to say that here. So now we have a gigantic map of position and character, and now we just need to find all neighboring plants that have that is the same type of plant. We're gonna make a function to split the plants into group, and I'll just call that split into groups, and we're gonna send in the plants, and gonna use sed to generate that function for us. So plants, then we could use a vec, but this will run a bit faster if we use a hash map instead. So hash map, and the key is the vec2. So vec2, and the value is char. And we want to return, and now we no longer care about the character, so we'll just return a vec of vec, and it should be vec 2, because we only care about the position after this. All right, we need to import it. Yes, that should not be like that. That should be like that. Okay. How do we split it into groups? There are many methods, but what I did is I create a vec of groups, and then I just pop one random plant from the set of plants, and then I get all the neighbors and remove them from the set and add them into the group, and continue doing that recursively. So I'll create a empty vec, and in the end we're gonna return that. So while let sum, and then we want the pos and the character, the position and character, and we can iterate over the plants. Iter, and next will return next if there is anything. If not, then we're gonna exit this loop. And also gonna dereference this, so we take a copy. Because we don't want the reference to a position, I think. Maybe it doesn't matter, but I think it does, probably. So we can create a group of plants. So this will be a group, and in the end we will push that group to the groups. And here we can create a recursive function that we can just say collect group, and we send in the position and character, and we also want to send in a mutable reference to the plants map, and a mutable reference to the group. And again, I'll use sed to generate that for us. I want to call this vec2. Same with this. And I want this to be a mutable vec2, and it's not gonna return anything. All right, so we have taken a position and a character. So first thing we want to do is check if the position actually exists in the plants. So if the plant actually exists. So we can call this C1 because we have C here. And this will be equal to plants get position. So if this is true, we want to check if C1 is equal to C. So if it actually exists a plant on that position, we want to check that it is the same type of plants as well. Then we want to remove the plant from the plants map. So by key, and we want to add it to the group. So group push, and we only care about the position. And then we want to go in every direction. So we want to go right, down, left, up. And we're gonna use a lot of directions here. So I'm gonna create a helper for that. So I'm just gonna call this dir. It's gonna return a vec of vec2, and this is going to return 1, 0. -1, 0, 1, 0, -1. So we're gonna iterate over every direction. So for each direction in directions, and we have to use into iterator on this one because it returns a vec, and otherwise the memory gets lost. But then we're just gonna call this recursively. So position plus direction, the character, the plants, and the group. All right, so when this compiles, okay, we have to say move here, mutable. And this has to be mutable as well. All right, so now we have split it, all of the plants into groups. Now this problem gets a lot easier. So for each group, we just have to find the area and the perimeter. And the area, that is just the number of plants in the group, and the perimeter, just check in all directions. If it's empty, then you add 1. So here, part 1 will be we iterate over the groups, and then for each group, we have to switches my keyboard. Group, and then we have to multiply the area with the perimeter. So it will be group length, that will be the area, times get perimeter for group. And in the end, we're gonna sum it. And we can also print it and assert that it is correct. Then we can generate that function. it's gonna return a usize, which is the perimeter. So all we have to do is just iterate over every position and then check if for that position, if in all 4 directions, if there is another position there, and if it's not, we're gonna count it. So group, iterate over it, map it, and we'll call this P for position. Then, so for each position, we want to go into each direction. So iterate over all of the directions. Then we want to filter only the ones that does not have a group. So we can call this P1 instead. So the other ones will be P2. And so filter, this is a direction, and here we want to again iterate over the groups, and we want to find and we can call this P2, where P2, the position 2, will be equal to P1 times direction. No, plus direction. Plus direction. So moved in that direction. So if we can find that, meaning if we can't find it actually. So if we move there and we can't find a B there, then we should count it. So is none, and then we're gonna count that, and in the end we're gonna sum all of the groups. And this complains because it's a reference. All right, and I think if we just declare that a usize, and if we run it, no, it panicked. Oh, right, we have to grab the input. Normally I prepare that. And now if we run, yes, we get the correct part 1. So then for part 2, it's pretty simple, that one also. If we take C, for example, you want to find every fence. So like this is the same fence. So first thing we're gonna do is we're gonna find all of the fence parts. So this one and 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 so on. And then we're gonna just group them exactly like we did when we grouped all of the plants. But this time we're gonna group them on if they are in the same part of the same fence. So can copy that out and then say part 2 usize will be equal to and it will be identical to this, except here we want to call get fence instead, and we can generate or get fence count maybe would have been better. All right, too late now. And this will return a usize. All right, so for the get fence, first we want to find all of the fence parts. So this one, this one, this one, and so on. So and it needs to be mutable for later. So this will be and each fence part we're interested in the direction from it's going in, and we can just use the direction from the part, because this one, it will have two fence parts, but they will be in opposite direction, and so we want to find later group them that they are in the same direction. So we can just say that this is a vec2, a position and a direction. So we can just iterate over the groups, and then because we might for each plant we might select multiple fence parts, we want to do a flat map. The flat map will take a position, and then we want to iterate over every direction and see if that is a fence part. So filter, and this will be direction, and it is if group does not contain and it will be P1 plus direction, and it needs to be a and this needs to be a vec out of vectors. After we have filtered it, maybe, okay, can't do format while it's after we have filtered it, we want to map it. So again, direction, and we want to select both the position and the direction. In the end, collect it. This gets super messy real quick, but yeah, I think it's correct. I think we need to move here. Right. Cannot be built from okay. We have all of the fence parts. So next step is we just want to reduce the fence. So combine all of the fences that are of the same type. So we'll just do a count. That needs to be mutable, of course. In the end, we'll return count, and then while let some part, and this will be the fence part, would be fence parts and pop. It will remove the last one, but it doesn't matter the order we do this in. Then we want to make sure that we remove all parts that are in the same fence as this one. So we're gonna create a recursive function for that. So reduce fence part, and we have to send in mutable reference to the fence parts. And here we're gonna count that by 1. And we can generate that function. And it shouldn't return anything. It should just reduce the fence. So pretty simple. Just iterate over all directions for each direction. We have a position that would be part 0 plus direction, and then we want to see if there is a fence part at that position that has the same direction. So let some, and we're gonna get the index because we want to remove it. The fence parts, iterate over that, and position to get the index. Call this part 2, and part 2 direction will be equal to part 1 direction, and part 2 the position should be equal to position. So if that index exists, we can call this part 2. So fence parts remove index, and remove returns what you removed. And then we're gonna just call this recursive. So reduce fence, but not for part. We should do it for part 2, and fence parts is correct, and we call that part, right? Yeah, and I think. Yeah, direction not known. Direction is in position 1. All right. So that was part 1 and 2. A little longer video. A lot of grouping code. I think most of that could be moved to a library, so you don't have to write as much code. Because like splitting it into groups, this could be a completely generic function that just takes a vec and a lambda expression and just splits it on that instead. And then you would basically cut the code you write in half. Reducing the fence maybe could also, because like it's 120 lines. So and obviously this could be already something you prepare, because a lot of these puzzles are similar. You get a lot of grids, you get a lot of that you should split it. Yeah. All right.